Good Wednesday to you, everybody, in Gov/Com 603. Welcome to week, boom, 7. Let's get this week and this video off to a good start. Much better. I am here now, your sufficiently caffeinated communication instructor. Also, I should mention, your sniffly communication instructor. It's allergy season, and I am one of the seasonal sufferers. Okay, week 7. We are, this is sort of this is like pinnacle week, because when we tilled over and started to week 8, then we're moving into the backside of the class. So we're right at the point of halfway. So a couple of important announcements for you. First, normally what I do is at the end of week 7, I grade your discussion posts. So there have been some of you who contacted me and said, hey, can you tell me how I'm doing? And which is, that's perfectly fine. And by the way, if you ever want to get, some feedback, or you want to have a conversation about the material, the class, your performance, your grade, all of this stuff, please don't hesitate to give me a call and catch me during my office hours, and I'll be happy to talk with you. All right. Your part one of your papers, I'm grading them now. I should have them done no later than Monday. I will admit I got a little bit later start on them than I had intended. I had my own sort of encounter with Hurricane Helene that has set me back a bit. I'm okay. I'm warm and dry. Just sniffly, which has got nothing to do with the hurricane. But again, especially for this first part, if you have questions about what I write, please contact me. Now, I will tell you, for some of you, you're going to get a note from me if you haven't seen it already, okay, that I'll ask to speak with you. Now, this in no way means that you're in trouble. It just means that there's some things that I want to touch on to help you as you move towards the completion of the paper. Okay, so if you see that note from me, please reach out. If my office hours don't work for you, let me know a time that does, and we will accommodate accordingly. Okay, all right. Also, for this week, just as a reminder, you have a midterm exam coming up that will open on the 15th of October and close on the 16th. And I know that that's, practically 2 weeks away. And in, graduate school time, that seems like forever. But I want to just remind you. And again, how do you study? Go back, look at the discussion questions, make sure that you understand the concepts, and especially can define the terms. Right, both in terms of like, say if there's a multiple choice, what does this mean? Or this means this, true or false. You're Johnny on the spot. Okay, but as well, if you were asked to say, explain what analytical narrative means, that's from this week. So if you haven't heard it yet, or if it doesn't ring a bell yet, don't worry. All right, that you could be able to do that, and if you can do those things, then you're going to be all ready for the exam. Now, the exam is going to be closed book, no notes. I'll put this in the exam instructions, but, I want to point out to you, remind you that whenever you're online, and this is just the way the online world works, folks, whenever you're online, there is something, and then on the other end of that thing, someone that can see what you're doing. Canvas is no exception. When you're doing an assignment in Canvas, and we may or may not like this, but it just, and by the way, the same applies for me when I'm working as an instructor in Canvas. There are features in Canvas watching what I do and recording what I do. And then there are individuals that look at what I do. All right. The same is true here. When you take the exam, Canvas is going to be watching and recording what you do. So when the instructions say, I'm trying to be as encouraging about this as I can. When the instructions say no notes, no other material, and you use other material, it's going to be recorded, and then I'm going to see it, and then we're going to have a difficult conversation that I really don't want to have. All right, we really don't want to have those conversations. Okay, so go through the discussion material, prepare yourself well, and you'll do just fine. Okay, so for this week, we're going to be taking a look, that is week 7, excuse me. We're going to be taking a look at analysis, and specifically, we're going to be looking at some of the qualitative sides. So we're going to, you're going to be asked to, for instance, explain what is an analytical narrative. All right. What does that mean when we say that analytical narrative? And again, be able to identify it and to explain it. Okay. Also, most research projects, both in terms of how they're explained and in terms of how they stand or fall, do so grounded in their methodology. You can find research projects on any, everything from what happens if you get live jumbo shrimp drunk, and that's an actual study, to what sort of facial expressions do and don't help a candidate during a debate, which seems a lot more practical than drunk shrimp. Anyway, so it's not the topic that necessarily determines whether a research study is going to be a success in the sense that it attracts interest and people go, It's the methodology. So this week, you're going to be asked to think a little bit about your methodology and how it is that a good methodology is constructed. Okay, that's also part of it. And we're going to be reading Pauner and Howard, both chapter 5. Okay, and then there are a couple of questions, exercises at the end of Howard that I'll have you take a look at that will help you with concepts like analytical narrative and analyzing your methodology. All right, that's this week. All right, let's take a look at your questions from last week. Read some of your answers and see what we can add to it, if anything. Okay. From week 6, question number 1, what are some of the ways to improve external validity? Describe how you would improve external validity in your proposed research design project. Okay. So remember the very point, as the French would say, the raison d'être. I love the French, and I love French, my first, second language. The very point of a research study is to ask the question, well, what's going on with everybody else? And unless you're just studying that group for studying that group's sake, which can happen, especially in anthropological studies or demographic band studies. We're looking at this ethnicity with this gender. Okay. And even within that, outside of your test subjects, you want to know, does the behavior, do your conclusions apply to everybody else? That's external validity, all important. Jennifer, you went first. Let's take you first in terms of your answer. One way to improve external validity based on and I think you left something out here, is to do a good job of drawing a sample from a population. Exactly. Now, we're on a presidential cycle. If you take a look at the polls, you'll see what appears to be at times contradictory indications as to who is in the lead and by how much. Now, most of the reliable polls have candidate Kamala Harris ahead by 2 or 3 points. There are some that place her ahead much further. But what you need to do when you look at a poll, and by the way, if what I'm about to tell you is hidden, that's your first giveaway that there's some, there's some flim-flammery, there's some trickery going on here. Take a look at the sample. From whom, from where is the data drawn? So if there's a lopsidedness in terms of percentage of respondents who identify as supporters of one political party as opposed to another, let's say there's like 55% Democrats and 45% Republicans, and that poll says, oh my Lord, look at this, it's a 6-point lead for candidate Kamala Harris, or vice versa. You know that this is not good by way of application to external validity, because there's a sampling. We call it a sampling error, and error implies like oopsie, but frequently sampling errors are study manipulations, and then researchers have various tricks and techniques to hide their sampling manipulation. Okay. So watch out for that. So good answer, Jennifer. And then we'll leave off on your particular project. Okay. Question number 2, briefly explain how proper use of the sample, the sampling frame, and the study population and theoretical populations can help minimize research bias, which is exactly what goes wrong with sampling. All right, Robin, let's take a look at you. Theoretical population is a large group of researcher hopes that their data will generalize to. Okay, that sounds a little twisted, but we get what you're saying, and you're exactly right. That's the point of doing the study. In doing the presidential polls, the point is to say, well, all of the electorate across the United States, this is where they're at, and they favor this candidate or that candidate by this many percentage points, etc. Okay. The study population is who or what one actually accesses and is also known as the accessible population. True. Good point. The sample frame is the plan as to how one will gain that access and is usually in the form of a list of all people who could potentially participate. Excellent, excellent, excellent. Okay. Important to remember in terms of the sample frame, it is, as you point out, Robin, the people, but it's also how will you get to them and what kind of questions will you ask them? Are the questions that you ask them neutral in their frame, that is in their setup, or do they push and encourage a particular answer? In politics, this is extremely common. In fact, in the world of polling, when data is being gathered, it even has its own name. It's called push poll. A push poll, POLL, not with a U, not poll. Okay, push meaning they're calling people, and I mean, I'll give you an example. This is rather ham-fisted. Those who are clever about it are a little more clever about it. You pick up the phone, you're like, hello, you don't recognize the number, so maybe you don't even pick up the phone, but you pick up the phone, you're hello. They're like, hi, I'm, may I speak with so-and-so? This is so-and-so calling on behalf of such and such polling group. And you're like, yeah, okay, why not? I get burned out on these kinds of things. So I usually pretend I don't speak English or something. But anyway, you go, yeah, sure. And then the question goes, okay, well, we just want to ask your opinion about some of the candidates. Can we, run a few questions by you? And you're like, yeah, sure, go ahead. Right. Okay. Could you, on a scale of 1 to 10, one being the lowest, 10 being the highest, rank how much of a threat you think communist Kamala Harris is to the United States? Now, I'm not saying Kamala Harris is a communist. I'm not saying she's a threat to the United States. I'm giving you an example of, real ham-fisted example of a push pull. The question itself is pushing a particular assumption. A, that Kamala Harris is a communist, and B, that Kamala Harris is dangerous to the country. That's a push pull. Watch out for that. In fact, look around, see if you can find some push pulls as the season goes on. They're easier to find than you might know. Okay, question number 3. Explain the following 2 terms: sampling distribution and sampling error. How are they related to the 68, 95, and 99% rule? Now, the second part of that question is where I really need you to focus your attention. 68, 95, and 99% rule. And I'll tell you right on the upfront, and you need to know this, those percentages are called confidence intervals. Confidence intervals. Remember that term. Okay. So let's take a look at your question, or excuse me, your answer. Andrea, let's do you. Explain the following terms. First of all, sampling distribution cannot be physically constructed because infinite samples would be required, which is not possible. Very true. Okay. So we've got to just, take a little bit. Standard deviation, spread of the scores around the average in the sample. Okay. And I'm going to come back and we're going to put some of these. You're correct in these, Andrea. We're going to put some of these into plain English, which, by the way, I want you to do for yourself. If now, Andrea and others who did a similar thing to this kind of answer, if you go standard deviation is the spread of scores around the average in the sample, and that makes sense to you, If you're still going, okay, what does that mean? Then translate it into plain English so it does make sense. Standard error, spread of the average around the averages in the sampling distribution sample size. Sample error, standard error above which provides awareness about the accuracy of statistical estimates. Okay, let's turn that into, good answer, Andrea. Let's turn that into straightforward English, and then we'll get to the 68, 95, and 99% rule. Okay. I think one of the reasons that this is that terms, not terms, but concepts behind the terms of sampling distribution and sampling error are hard for people to grab onto is many maintain this assumption, and I would even go so far as to say illusion, not illusion, that we are individualistic and we do not behave in patterns. Now, it's interesting. It's sort of like photons, it's light. Light's composed of photons, which is a particle, an actual physical thing, and a wave that is an energy flow. It's kind of a weird arrangement. Okay. Yes, we behave as individuals in groups. I don't mean we're only individuals when we're in groups. I mean, as individuals, we behave in patterns. Okay. And that's just human behavior. So, when you're doing a study, and let's say, let's pick something really straightforward. Let's say you want to do a study in which you're wondering, how does wait time determine voter turnout? That is, the number of hours that someone has to wait in line to vote. How does that affect voter turnout? Is it that the higher the wait time, the lower, the lines are going to go they go opposite, that the voter turnout goes down because people just go, I can't do this. And then they take off. Okay. That seems straightforward, pretty obvious. Then there have been a lot of studies done on that very question or subtle adjustments thereof. There is a lot of data that shows what the standard pattern of behavior for people happens to be when they're waiting in line. It's not as if you ran this study that you would go like, oh my word, I had no idea that this is how people behave. I'm getting my pad to give you an example. Okay, so when you plot data on a graph, and either a bell curve or a bar graph where the bars are all stacked together, and it creates, if you trace the outline, you get a rough curve, and that's called a histogram. Okay. What you want to look for, and you're rarely going to get this, all right, what I'm about to show you. But what you want to look for is a distribution, that is how the data appears on the graph, that is relatively reflective of a expected distribution. So here is a good distribution, and right in the middle of the distribution, this is what we call the central tendency. See, it's in the center part of the bar graph, and then we draw the lines where things start to drop off on the right side and things start to drop off on the left side. Right here in the band, this is where the majority of people in terms of their behavior is going to be found. This nice bell curve, and it's rare to get a bell curve that nice when you plot your data, when you do empirical research. But that is indicative, that indicates good sample distribution. If you get a graph that looks something like this, that doesn't mean you throw your study away. That is where it goes way up at the beginning and suddenly it goes whoosh, off of the downside. You need to check the data to make sure that you don't have something that's disturbing the distribution. Okay, so let me clarify that, a little bit further. Here, let's say you were doing the following as a research project. Okay. Let's say that you wanted to figure out how many times a a kindergartner could jump up and down? What was the average number of times that a kindergartner could jump up and down in 30 seconds? Why? You're in sports physiology. So you go to a kindergarten class, okay? And you line up 10 children. And you say, okay, you got to be enthusiastic about this. You say, we're going to play a really fun game. And here's what I want you to do. You stand in the line and, stand there at your desks. And when I point to you, you come on up here and look at me. And when I say go, and that's when you click your stopwatch, like deep, if I wore a digital watch, which I don't, I wear analog watches, but you'd be wearing one. And you say, okay, you say go deep, and you're going to time 30 seconds, and then you're going to stand there with your notepad, and you count how many times the child jumps up and down. So first child comes up, you say ready, set, go, and they're like hoppity, 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 hoppity. 30 seconds is up, and they hopped up and down 25 times, and you're like, okay, great. So you write down 25. And then the next child, you do the same thing and hoppity hoppity, and it's 28 times. You're like, very impressive. Almost one every second. You write down 28. And then the next one is 20. Okay, now you've got 3. And then the next one is 24. Now you've got 4. But the next kid in line, it's little Jimmy. And little Jimmy, he isn't too sure about this whole hop up and down thing. He would rather be outside kicking the ball. This whole exercise seems kind of stupid to him. It looks embarrassing to be hopping up and down like that. He ain't going to do it. So he comes up to the front of the classroom and you're like, okay, are you ready, little Jimmy? 3, 2, 1, click, you push your watch, go. And little Jimmy just stands there. You're like, come on, Jimmy, hop up and down. I know you can do it. Go. Jimmy doesn't hop up and down. Now, so your 5th participant, the number is 0. Standing behind Jimmy, your 6th participant is little Susie. And she's always thought that Jimmy's pretty cool. In fact, she might have a kindergarten crush on little Jimmy. Now she's like, well, he's not hopping up and down. Maybe there's something wrong with hopping up and down. She was very enthusiastic about the idea until little Jimmy. So she comes up and you're like, okay, Susie, when I say go, you hop up and down. Ready, set, go. And Susie's like, she's looking around. She's looking over at Jimmy. And he's like, and Susie is just hesitant. Come on, Susie. Times are running. Hop up and down. And so Susie, sort of, she wants to comply with you as the authority figure, but she also wants to be cool like little Jimmy over there. And 10 is the number of her hops. So now you're halfway through your sample. Okay? You've got 25, 28, 24, 0, and 10. And then you finish. And from Jimmy on back, the number of kids that hopped up and down dramatically, the number of times these kids hopped up and down dramatically dropped. Okay? What do you do? Because what you're after is you're asking the question, how many times in 30 seconds can a kindergartner jump up and down? Not how motivated are kindergartners to jump up and down when asked to jump up and down. That might be an interesting study, but that's not the study that you want. And when you plot your graph on your data on a graph, you get, instead of a nice average like this, you get something like this, because everybody on the front end of the study was hopping up and down, and then everybody towards the back end of the study were influenced by Jimmy. Okay, so what you need to do is you have to calculate your sampling error and say, there's mistakes in here. We're measuring something, but we're not measuring what we want to measure. That is, how many times can kindergartners jump up and down, 5-year-olds jump up and down, not how willing are 5-year-olds to jump up and down. And so normally what's done is the data that doesn't fit is taken out. Now you might be saying, hey, you're manipulating your study. Sort of. Because you're manipulating out information that is not relevant to what you're trying to study and is getting in the way. Now, here's the really interesting part to me as a researcher, because, especially with COVID and people running around wearing t-shirts saying, I believe in science, there's this strange, and I do mean that, strange bifurcation. Bifurcation is a split in the minds of many Westerners, Americans in particular, that there's religion over here and then there's science over here. And, one is above the other, and science disproves religion, and religion proposes things that science can't explain. Wrong. Here's the interesting part. Empirical research, especially analytical, empirical, quantitative research, assumes, okay, that the reality that you live in is so predictably ordered that things are going to happen in predictable patterns. And here's what we know about the physical world. This is a hard and fast, unbreakable physical rule. There is no order without an orderer. It just doesn't happen. So this is, porcelain, which is a form of mud. And then with a glaze, which is glass, which is sand. So basically, this is two different types of soil subjected to high heat. And then, shaped into this cup, subjected to high heat. I don't know who designed and they came up with a system to make this cup. Someone in China, I would guess. See if I can see without pouring coffee onto the desk. But I do know it was designed and made by somebody. How? Because if I took a lump of mud and a handful of sand and put them, let's say I've just put them out on my back porch and even subjected them to the same type of heat that cup is subjected to, when the blowtorch, putting the shield on. And I watched them and I carefully recorded with my notebook what happened. There is a 0% chance that material is going to spontaneously form itself into this specific design. All designs have a designer. And so in the operation of the everyday world, it's assumed that things are so ordered, in fact, they're boringly ordered, that there's predictability. And this takes us to the 68, 95, and 99% rule. And these are called confidence intervals. What do they mean? They mean that we can predict, and these are standard percentages, that 68, 95, and 99% of the time, whatever we think is going to happen, happens. And here's the important bit. If something different happens outside of those percentages, we assume that there's some force acting on the normal pattern. And it's usually that force that we want to study, that we want to try to take into account for. I will give you an example. All right. If you take a coin like this quarter, and you do this in pairs, and one person flips the coin and looks at the coin and says heads or tails. Okay. And they do that 100 times, 5 times. And then the other person takes 5 sheets of paper and for each 100 times writes down heads or tails. If you count up the number of heads and if you count up the number of tails, and then you take the average from the 500, you should expect at a minimum that 95% of the time there's a split between heads and tails. And what does that mean, 95% of the time? That means that, it's not going to be 50 heads and 50 tails all the time. It's going to be like, 52 heads and 48 tails or whatever. That's what you will get unless there's an external force acting on the coin flip. Like what do you mean by external force? Well, let's say that you see the percentage of the time is not 95. It's actually lower. It's like 70% split between heads and tails. What's the external force? Well, maybe it's a trick coin. And the head side is heavier, so it tends to make tails come up more. That's an external force. Maybe the partner that you're working with is a knucklehead and they're just not paying attention, and you're saying heads, tails, and they're like, huh, what? That's an external force. Trick coin, knuckleheadedry. Okay. Or maybe even worse than knuckleheadedry, the person that you're working with is just a pain in your neck. And when you say heads, they write down tails just to mess with you. Okay. So trick coin, knuckleheadedry, pain in the neck. These are external forces that are interrupting the normal prediction of 95% expected distribution. That's the confidence interval. Now, why 68, 95, and 99? Well, because it depends on the behavior, the thing that you're studying. A lot of human behavior falls into the 68% range that we can only predict and normalize patterns about 68% of the time. Most inert physical phenomenon, that is, they just happen because of the physical laws, about 95%. When you start dealing with, especially in the pharmaceutical industry or the chemical industry, you're looking for 99% predictability. So what's interesting is if you look at it like a cone, the closer you are to the operational laws, the physical laws that govern our universe, like say that, how chemicals interact, the smaller the percentage outside of the confidence interval. The further away you get, so now you have a coin which is made out of metal and it may or may not be balanced, and there's somebody calling heads or tails. So now you're moving further away from the physical laws. Then the confidence interval goes down. And then you get out here in the cone to human behavior. There's all kinds of complications with human behavior. Then the confidence interval changes. Okay? So you need to understand what those numbers mean in empirical research. Very, very important. All right, and we're running late here, so let's try to wrap up. Question number 4. Explain the following two terms: stratified random sampling and random sampling. How are the two practices related? Andrea, let's take you again. A stratified random sampling is known as proportional. The quota of random sampling. Stratified means formed into layers. Therefore, the implication means stratify the sample after separation or articulation of the sample. Okay, let's put this into English, and that's right. This is really common in politics, in political science. Okay, so you have random sampling. That's just anybody in the electorate. Doesn't matter. Let's say just anywhere between, when you can vote 18 and when you're dead, whatever that mean age now is for, men and women. I think it's 80 something, 70, no, maybe 76. Maybe I'm shooting a little high. Okay, in between those two. Random is like anybody in there. Or you could start to look at specific groups and take random samples within those specific groups throughout the whole sample. Women between the ages of 18 and 25. Men between the ages of 18 and 25. Voters with income between 20,000 and 30,000. Voters with income between 100,000 and 125,000. You take the sample and you start to look at the specific behavior within various identifiable labels within the sample, but you're still randomly picking within those layers. That's stratified random sampling. It goes on. It's extremely common in political science because one of the current formulas for political success, and the first step of political success is to get elected, is to target specific stratifications, specific groups in the electorate, and then craft a message that sounds good to that group. And I'm not going to name any names, but of the two presidential candidates, there's one that seems to take this to an absurd extreme. And this particular candidate that, news commentators have poked fun at this candidate because this candidate seems to adopt strange linguistic malutations, accents when this candidate speaks to certain groups. And despite the fact that this candidate was raised in a very affluent family situation, there's nothing wrong with that, being raised in affluence. Okay, this candidate takes on the linguistic and the accent persona of groups that the candidate is speaking too. See if you can figure out who it is and find instances of those. Okay, that's not stratified random sampling, but that's the individual trying to connect with that stratification in the sampling. And then I will bet you dollars to donuts that there's some pollster following this candidate around, taking samples of people saying, "Oh, did you like the speech? And did it speak to you? And is it meaningful?" And then pumping feedback into how the next speech is crafted to that stratified group. Okay. All right, everybody. We're up on a half an hour here. Plus, it's longer than I normally like to make these things. You're near halfway point. Hang in there. Keep prepping for your midterm exam, which is coming up in about 2 weeks. And I will see you on Canvas. God bless. I'm praying for you and I'm thinking about you. And if you need anything, reach out. I am here for you. Okay. Bye-bye.